So welcome to our session on local news. My name is Dan Kennedy. I'm a professor in the School of Journalism here at Northeastern. My research area is the future of local journalism, and my current book, co-written with Ellen Clegg, is called What Works in Community News. So I'm really interested to learn more about our panelists' work, and we're going to get right to it. I believe that you have in your program somewhere a description of the papers that you're going to be hearing about, so I'm not going to repeat all of that. But I'm going to begin by introducing Doug Beeferman, who is a research engineer at MIT's Center for Constructive Communication. His current research interests are semantic search and discovery for local media data sets, topic detection, and tracking of misinformation on social media, machine learning-based approaches to conversation analysis, media numeracy, and how vaccine hesitancy and access are reflected in online search media. He is going to present a paper that he was the co-author of called Search and Discovery of Local Government Meetings for Journalists. In addition to that, I understand that Professor Beeferman is going to be introducing a colleague of his who will be part of the presentation.
Thanks. So I'm going to power through this because I'm dividing my time with my colleague Yuan Lee, who's here from, he's a writer with a computer science background from UCSB. This talk is called Search and Discovery of Local Government Meetings for Journalists. These are beautiful city halls from around the United States. This is Boston City Hall, which is arguably not beautiful, but it really depends who you ask. It's just a couple miles walk from here. I encourage you to visit. So city halls contain the stuff of local democracy, the stuff that decides what you see and hear and feel if you live in the city. So every week, or sometimes multiple times a week, council members and the general public convene to make decisions, pass legislation, approve budgets, decide on how land is used. And in almost all city council meetings, at least throughout the US, there are public comment periods in which everyday citizens can show up and air their grievances. So if we crack open just one of these city council meetings at random, we might find someone like this Boston city councilor talking about the problems of the day. So a particularly urgent problem facing Boston is the drug overdose epidemic. In this case, the councilor is talking about specific intervention of offering fentanyl test strips to drug users to test to see whether their drugs are laced with deadly fentanyl. What I find fascinating about city council data is that very similar policy discussions are happening in parallel in hundreds of places at the same time. So if we just zero in even on something as specific as what I just described, fentanyl test strips, we'll find nearby in the Northeast several other councils weighing how and where to offer fentanyl test strips. Actually, just in the last year, hundreds of different councils debating specific ways of implementing that policy. So for me, it's a really interesting data set from the perspective of possible cross-pollination opportunities. If we take a look at the topics that are being discussed, we find everything under the map. These are some of the more popular topics as, I've implemented a thing that finds the sentence embeddings for all the sentence spoken in these meetings and then does a clustering that may be familiar to some here called bird topic to identify some of the popular topics. And we find things like drugs and gun violence, but also really more micro things like bike lanes and sports and pickleball and other issues of the day. So we created the search engine called Civic Search. It's kind of, you can think of it like Google for these transcripts, except in addition to a keyword search field, there's also a place field. You can search by topic and location. The data is organized along three axes: topics, keywords, and places. Right now we're up to about 140,000 meetings total. It's almost 1 billion words. I should say right now it just processes YouTube transcripts, but we hope to include other platforms. More and more of these city councils are online these days, especially since the pandemic. A typical keyword search gives you the correlated places, topics, and terms to help in discovery, time series showing the trend line for the topic, and then excerpts which you can click on to actually play back the videos. There's also a city detail page for every city. Here it is for Boston, so you can see what the top issues facing the city are and what the distinctive issues facing the city are. And then, importantly to our users, there's a map which shows which locations are being mentioned in the meetings. And then here's a similar thing, but for the topic dimension. Every topic has an LLM-generated summary with citations, followed by a list of which phrases are correlated, and then the places that are discussing the topic. So you could, if you're interested in deep diving on drug policy, you might open up the drug topic, and you'll find something like fentanyl test strips there as a possible story lead, as something to consider writing about. We also have made available some resources for researchers, some of the kind of raw data behind the search engine, which will allow you to analyze the keywords yourself. What I'm showing here is a chart of the percentage of time that is spent talking about drug policy versus the actual drug overdose death rate rolled up to the county level. And okay, there's an email alert feature. I'm going to sort of skip past that. So I just wanted to talk about how this thing's actually being used. We have about, since launching, which was a really soft launch in February, I've seen about 22,000 unique humans use the site as far as best I can tell, with about 300 or so signed up to receive alerts on keywords. By and large, most of those users are just referred from search engines like Google and the things that they're interested in. There's a long tail of topics, but it leans toward things related to licensing, drug policy, affordable housing, and other housing and safety related topics. We've seen, in terms of the specific people who have corresponded with me after using the tool, a lot of nonprofits and consultancies in transit, energy, and education, and then some commercial things that I didn't expect, like real estate agents, municipal bond funds, and such. Are probably the biggest visible success that I've seen the tool have is a news story that was written by Brandy Zadrozny of NBC News. She covered a white nationalist who was elected to the city council in a city in Oklahoma, and she she just happened to write an Ask Me Anything on Reddit, which is a rare treat for a webmaster to see this. She describing how she used the site to find the activity, and then she wrote this big piece, and a month later, I'm not saying there's any causal connection, but a month later the guy was actually recalled. Okay, I'm going to hand it over now to Yuan, who's oh, sorry, actually, yeah, go right ahead, come on. This Civic Search also has this newsletter series. I like to joke that this is an example of AI creating a job in the following sense. I wanted to create a bi-weekly newsletter, and I imagined a year ago that it would be entirely LLM generated. I started to use LLMs to generate the newsletter and pretty quickly realized they're terrible in many dimensions. So we write these bi-weekly newsletters and deep dives on different topics, but so I hired a writer, so it's an example of AI creating a job.
Yeah, my name is Yuan, and yeah, I write most of the newsletters. I want to start with a question. How many of you live in Boston?
Or the area?
Yes. Okay, a fair number. So you may be familiar with something called participatory budgeting. It's something that Boston's trying out for the first time this year, and we covered it in a recent issue. For those unfamiliar, participatory budgeting is basically where residents get to vote on how the city spends its money. This is actually not how things work in most places. And people have opinions about that. We'll start with a fellow named Frank Baker, who at the time of recording was the city councilor, or the counselor for Boston's District 3.
As I say, participatory budgeting. Dangerous, dangerous, dangerous. I see people that aren't elected, that aren't even from the city, walking in and out of this place, and they have more say in this than I certainly did. Then again, I didn't really avail myself very much, so I'm not going to get into that. But there's people here that don't even live here, don't pay taxes here, don't have kids here, have never coached or mentored any children here. They've got more drag, more say on this budget than anybody in this room here.
And next up we have Ellen, a resident of Oklahoma City, Cleveland, Ohio.
Why deny a sophomore at Garrett Morgan, not yet old enough to vote, but juggles a part-time job, the opportunity to demonstrate how public spending can be used to keep him and his friends in school and away from violence? Participatory budgeting elevates all three of these voices and more. Is that not something we deserve? Participatory budgeting is a clear commitment to the Clevelanders who never left, the Clevelanders who came back, and the Clevelanders who will one day call this city their home.
Now, as researchers / journalists, I think we've all struggled with how do you find people and how much can you generalize? This is where I think Civic Search can come in handy. Now, I live on the other side of the country, and yet I was able to find those examples across different cities, different states, and different dates. And there are dozens, hundreds, thousands more like these. And that's how I write most of these newsletters. I pick out 20 or 30 videos from Civic Search and I start taking notes. By the time I'm done or satisfied, I am typically around 20,000 words, which I then narrow down to maybe a fourth or an eighth of that. Now, AI. We include an AI summary on some of our search pages, and I typically have an AI draft that I start with. And in theory, now, I have a bachelor's degree in English, so if you're someone rolling your eyes right now, I totally get that. But in theory, these should be exceptionally useful for sorting through tens of thousands of hours of motions and seconds and points of order, and basically stuff no one wants to look at, right? But in practice, unfortunately, there are some problems. The AI has a tendency to repeat cities, the writing is kind of dry, and it's prone to grasping at straws. What I mean by that is, for example, the AI makes a big fuss about Albuquerque, New Mexico here, but when you actually click on the video, first of all, the person talks about light bulbs, and second of all, when you do get to rent control 20 minutes later, the rally and union part of it only comes up briefly. That said, the AI does try to cite videos from the Civic Search database, and I typically find that these videos are more relevant than just clicking on the results page chronologically. So clearly the AI is detecting something, so those are the videos that I typically take notes from. Now, we deliberately emphasize city council meetings. We leave the double-blind, placebo-controlled studies and on-the-ground journalism to you, and I think that that emphasis is precisely precisely how Civic Search brings a dimension to journalism and storytelling that has so far been underrepresented, because we're more polarized than ever. Online vitriol is at an all-time high. And anonymized disinformation is wreaking havoc on our institutions. But in city council, making an argument or an accusation means putting your real face and your real body on the line and behind the podium, facing not a swarm of pseudonymous bots, but your very own neighbors. And it's these people that you've got to convince that your idea will help make the city, this city, your city, a better place to live. These may very well be one of the few places left where community and consensus, policy and principle, democracy and debate not just abide, but still preside. And we hope that whether you're researching trends across cities, keeping tabs on certain topics, or just curious about how your city works, you'll use Civic Search to find that undiscovered country, to write that next great story, to see that perhaps the key to saving democracy lies not in some far-flung Oval Office, but simply on the other side of town. Thank you.
Next up, we have Kai-Cheng Yang, who is a postdoctoral researcher in the Laser Lab at Northeastern University's Network Science Institute. His research aims to uncover how technologies like generative AI are used for deception and disruptive purposes, study how humans react to these abuses, and develop countermeasures. Specifically, he focuses on bad actors like malicious social bots and misinformation on social media. He is the co-author of the paper, Google Searches Regarding Politicians Are Dominated by a Few Nonpartisan News Sources.
Sorry, that's actually another paper from the morning session.
That's a peaceful, that's what you would be doing. But
Don't worry, yeah.
present away, thank you.
Thank you. I'm just going to start. Hi, everyone. My name is Kai-Cheng. So today I'm going to talk about the other project, revealing the localness of news domains through consumption patterns on social media. You know, despite all the description about my work about AI, this one is actually not about AI. So I'm actually going to skip the part where why local news is important because everybody, that's why you're here, right? So. But our research question here is how local are the local news outlets anyway? Or another way of saying is that we want to see how can we classify different news outlets or news domains as local or national. So that's a very practical question, right? So if you look at the literature, that's what I did. It's actually pretty tricky, right? There's no clear standards, but if you look at the literature, there are like different ways, or different things people focus on. Like for example, you can focus on the coverage, so the content should be relevant to local communities, or you can focus on the production, so you have to be physically located in some places, or sometimes you have the name of the place in the brand, right? Or you can focus on the audience where the readership is concentrated in certain areas. So that's where we are. The third one is what we are focusing on. So basically, we're doing a data-driven sort of approach to classify domains into national or locals. Let me tell you a little bit more about our data set. So we have this what we call a Twitter panel data set. We basically match the voter registration record where we have all the location, all the demographic information against Twitter users. So we end up with 1.5 million profiles, and we collect their tweets from 2011 to 2020, and we extract the URLs they share through the years. And at the end, we end up with something like what we call a domain sharing activity table. So basically, with the data we know, for example, New York Times has been shared once by someone in New York, right? And similarly, you have a very large table. And with this table, we can do a lot of interesting things. So here we are trying to measure the localness of the different domains. So to give you a sense of how this works, right? First of all, you can imagine we have some expected distribution of the audience. It's not evenly distributed across the states because different states have different number of population, right? But there is this, and we don't know that, but because we have a very large data set, so we just basically aggregate all the sharing activities of all the domains we have, and hopefully all the noise cancel each other out, so that you end up with a expected distribution. So that's our baseline. And then you can compare the distribution of individual domains with this baseline and see how, are they similar or are they different? Like, for example, if we have a national domain, then you should expect to see that the distribution of this domain is close to the baseline, right? So that's what's happening here. And but you can also have those local outlets where the readers are concentrated on certain areas. So you can see the other two cases down there. It's more overshared in certain states, but less shared in other states. So that's our idea. So that, in order to quantify this, basically we're trying to quantify the difference between the individual, the distribution of the individual domains and the expected domain, right? We're comparing two distributions. So we're using something called a KL divergence. So I promise this is the only equation in this presentation, and I'm not going to dive into the details, but that does exactly what I described. It measures the difference between two distributions, and when the two distribution is the same, you're going to get a number of 0. But if there are differences between the two distributions, then you're going to have a number larger than 0. So we're going to use this number as our measure of localness. And then we just calculate this for all the domains we have. So to give you a sense of how things look like, in our data set, we basically have information for about 130,000 domains, not necessarily all news outlets, pretty much everything we have, but a lot of news outlets in there, right? And on the left, we are showing you the sort of the joint distribution of our localness measure and the number of users, unique users who shared this domain. And then to give you a sense of how it works, I picked like 3 examples. The first one is CNN, so it's kind of a well-known national news outlet, and you can see it's being shared by many users, and also the localness score is close to 0, right, up there. And then we have News9 and wikilocal.com. You probably don't know those, but one is a local news agency in Oklahoma, and the other one is in Boston area. And you can see both of them, they're being shared by less users, and also the local news score is kind of bigger than CNN the case, right? And also on the US map, you can see for News9, it's brighter in Oklahoma, and for wikilocal, it's brighter in Massachusetts, although it's kind of a small on the map, I promise you it's the case. So hopefully that gives you a sense of how our measure is working, right? But how do we know how well it works? So we try to compare our measure with some existing data sets. So I just dive into the literature and collect all that's sort of available and have a binary classification in there. And after combining everything, I end up with about 13,000 unique domains, and the intersection with ours is like about 5,000, but that's only like 4% of all the domains we have. But we're going to use those to measure. And basically what I do is, because we have a continuous number, right, I'm basically using our number to predict the label of whether it's national or local. And I'm using a measure called AUC. Again, I'm not going to explain what it means, but if it's close to 1, it means it's like doing a really good job, and our score is like 0.98. And again, because our measure is a continuous number, if you still want to get a binary classification using our measure, we would suggest using the number of 0.24. So that will basically classify them into national or local. So here I'm giving you some examples of the, like on the left, those are like the most national sort of domains, and you can see it's some of the well-known news agencies, right, kind of expected. On the right is some of the domains with the highest local news score. Those are like less known, but I checked them. Usually they are like some local news outlet. So that's another way to give you a sense of how this is working. So to summarize, basically we're here trying to propose a data-driven method to quantify the localness of different domains, and I think it has a lot of nice features. And if you have similar data, not necessarily Twitter data, you can try the same thing. And we plan to share this metric very soon. But before I go, there's actually one more thing. Remember earlier I mentioned that we have the voter registration record, right? So we not only have their location, we'll also have the people's race, age, gender, and the party information. So using similar approach, you can actually calculate like different measures of those domains. Like for example, the political bias, like the gender bias. So we actually plan to share all those metrics. Hopefully that could be useful for some other analysis. And to give you a sort of a sneak peek, we actually made an interactive app which is available now. So if you want to try, you can actually go there and check different sort of domains. I think I still have some time, so let me do a quick demo here for you. So this is our interactive app. So right now it's showing like a CNN. You can see this is the localness. And you can go down and see the deviation of the race distribution. You can see the age distribution. You can see the political bias, gender bias. You can try all the other things here. Like for example, because we're in Boston, so let's try. Please be working. Okay, it's working. So even though Boston Globe has a globe in the name, but it's sort of local. It's being shared by many users, and you can see it's being overshared by people in Massachusetts here. And then you can check, for example, the race distribution, age distribution. For age, you can see you see a lot of older people than the baseline sharing this, right? For party bias, I think is slightly left-leaning. And but for gender, I think is kind of in the center. So you can try. As I mentioned, we have like 130,000 URL in there, domain in there, so you can play with it. And I guess that's all I want to share today. Thank you very much, and I want to thank my collaborators. And if you have any questions, feel free to reach out to me and stay tuned, because we really try to make this data set available to the research community. Thank you.
So our next presenter is Marianne Aubin La Quéré, and on her website she says, "I don't care how you pronounce my name." So if I botch that, I guess I'm off the hook. She is in her final year in an information science PhD program at Cornell University. Her work traces how AI and other emerging technologies affect online news and civic information consumption. Her aim is to help keep the public informed and civically engaged in an accessible, transparent, and equitable way. She is the co-author of the paper that she's about to present called "Towards Identifying Local Content Deserts with Open Source Large Language Models." So thank you, and take it away.
All right, never mind. We're going to do this. No notes. Let's go. Cool. Everybody can hear me? All right. Thank you so much for the lovely introduction and the lovely pronunciation. Hold on, let me get my time so that I don't go way over. So like Dan said, my name is Marianne. I'm based out of Cornell Tech. This is a collaboration with the Brown Institute for Media Innovation at Columbia as well, and we also worked with Tazia, who was at the city at the time that we were doing our collaboration here. And so we started from this definition that you're all probably quite familiar with, which is most commonly news deserts are defined as geographic areas with no physically proximate local news organization. And what we're really asking in this question, in this study, is what happens if we think beyond news deserts and think about content deserts. So we try to define content deserts as geographic areas that are systematically undercovered or not covered at all by any local press. And I really want to highlight those two parts of that definition, right? One of them is thinking about areas that are not covered at all, which would be more similar to how we're currently defining news deserts. But the other thing that I think is interesting is that a neighborhood or an area could be actually being covered, but this coverage could be systematically biased in some way, which we argue would also constitute a type of content desert. If an area is only being talked about with regards to crime, then you could imagine that would have harms for that community. And so one phenomenal example of this kind of work is by April Lindgren, where she goes in and actually hand labels and maps many stories from the Toronto Star in Canada and uses that to build up an argument that there are high-need neighborhoods that are being underreported on in the coverage. And one of the things that is key to that is that, again, she went in and manually, each location that was mentioned in an article ends up somewhere as a dot on this map. And so that's the problem that I've been thinking about for months now, is how do we get the dots on the map? And why should we care about this? One is you can put dots on a map wherever, which is lovely. So this is a scalable approach. You can also pair it with underlying demographic data. And we think about these things together as enabling us to have conversations about community. And often with local news work, we are thinking about how well represented communities are, how well their needs are being served. And so we think that putting those two things together is quite powerful from that perspective. I will not go into this in too much detail, but obviously you have human labeling on one side in terms of identifying locations. And then what we've been thinking about is what is it that large language models might introduce as a way to identify locations. And here are the two things I want to point out, especially relative to named entity recognition, is this idea that these are highly context-specific texts where you're already assuming that you are in a location and the reader may have information about that place. And so a large language model may be able to identify local locations more easily. So if you mention something like Doug was saying, City Hall, the language model might know that it's in the context of Boston and actually be able to find it in a way that named entity recognition would need more training. I will say there's a problem here with bias in terms of areas that are going to be more covered in the news, ironically, are going to have more training data, and so it's going to be able to label those better. And the second thing that we think can make these models very powerful is their ability to disambiguate based on natural language. So if you say, the 7-Eleven 2 blocks down from City Hall, a language model is going to be able to interpret that much more easily than something like named entity recognition. So that's our thought process behind this. But I also brought out here that there are distinct ethical concerns that it introduces. We tackle some of those by using only open source model in this work. But like I said, the bias one is really the one that I'm primarily concerned about. And so our framework for proposing this, I will run you through one example that I think of as a case study right now, but is really, you have the article data set, you tag it with whatever metadata might be of interest to you. So, in your case, it could be something like the actual amount of drug overdoses would be one type of metadata that's underlying it. Whether it's talking about fentanyl. And then you can map it to underlying census data. In this context, the article data set that we pick, we are based in New York City, so this is our local context, which is where we've started this work. So we use the New York Post on one side, which is, tabloid, conservative-leaning, clickbait type content, and the City, which has much more investigative pieces that are often talking about government and politics in a much longer form. For metadata, right now we're just using news topic, pretty straightforward. Again, we think of these things as all a little bit changeable and malleable. And then we're right now analyzing this data at the zip code level. Census data obviously is available at many different layers, and individual cities like New York actually has specific neighborhood level data, but not everywhere is going to have that. So we think this is a nice in-between of somewhat granular, but not so granular that you can't do any kind of statistical analysis. And then I will run you through sort of, again, this problem that we're mostly focused about, which is the idea of labeling and mapping specific locations. So for validating, we picked 50 articles from 3 data sets, the New York Post, the City, and then a random news headline data set to see how well it would generalize. We had a set of crowd workers. We got about 4-ish raters per article to supply the locations that they think are mentioned in an article. We then tested a bunch of models and prompts. And I'll just focus for this presentation on the best performing one, which we gave a local journalist role to. So that's interesting that actually that was the best performing prompt. And just a little bit more, we then come to this task where you have a set of locations that are provided by crowd raters and then a set of locations that are provided by a model, and you're trying to see what the overlap is between the two. And so the first thing we do to disambiguate between something like, if somebody says NYC and New York City, we want to know that that's talking about the same singular location. So we geocode that with the Google Maps API, and then we consider in the crowd worker dataset any valid location to be a location that at least 2 people have identified. And then that is when we do our comparison. In terms of the performance, what we see is that on average, the model is actually returning more locations than the crowd worker dataset. And about 75% of the locations that the model identifies are also in the crowd worker dataset, but only about 60% of the things that the humans are identifying are also in the model dataset. And so we looked at this initially, and 75% is okay, but it's not phenomenal, especially compared to some of the named entity recognition approaches that I've talked about before. And so we looked at the mismatches one by one. And what's interesting is actually almost all of them were, I would say, at minimum defensible. And in a lot of cases, the model was performing better than the crowd workers. The first one, which, again, all of this is things that we're planning to tackle in future iterations, but is you can have different ways to represent the same data. So if the crowd workers are saying Oceanside and California, those get mapped onto separate locations compared to Oceanside, California. The second thing, and this is something that we did see, is that we did not filter. We know whether or not crowd workers were from New York City, but we did not select crowd workers in New York City. And so something like Dumbo is a neighborhood in New York City, which the model recognized, but the crowd workers did not, which is very interesting. And then, again, in cases where the model was supplying more locations, often these were actually locations that humans had missed, especially when you're dealing with long articles, especially when there were a lot of locations to go through. And so I think that could be tackled with having many more crowd raters or iterating on this a lot. We're not going to do that. We are going to be supplying expert labels and doing expert labels ourselves from people that live in the area. And so that's our next step for that in terms of really getting the validation metric down. I did want to present an exploratory analysis that just shows some of the potential for this method. So here I tagged about 3,500, again, from both of those samples. This yields 13,400 locations, about 42% of which are in New York City. As you can see, a lot of them are government and politics, and that's because the city's coverage is quite heavily leaning on that topic. And then sports is going to be highly represented from the New York Post dataset, and crime is definitely a bit of both. And what's interesting here is, so if you look at the most covered locations, these are locations that span a big area, right? And we've made the choice to detail them as points, which we could talk about, but these top ones are all actually larger areas. And so it becomes really interesting when you map them, because you can see the points. Ooh, wait, where's the pointer? Is this the pointer?
Yeah.
No.
You have to bring your own. Wait, really? Yeah. You guys are both of them? Yeah.
Oh, okay. Never mind. So what's interesting is the clusters that you see are actually these larger locations over there. So for example, this one down here is actually New York. This one here is Manhattan. And the thing that's interesting is if you look at coverage of the city, you can see it's actually quite spread out. They're covering a lot of individual locations around New York City. But if you look at the New York Post, a lot of their coverage is really clustered around these broader areas. So they're not as much talking about individual locations. They are really focusing on these bigger kind of points, which starts to let you imagine how their coverage looks. Then when we break it out by topic, I think the left one is, there's a lot more going on, but the two that I found interesting is if you look at this green crime dot in the middle, that is in fact Rikers Island. And so you can imagine that would make sense. The other one that I find interesting is this gray one that is low, where I said that is actually mapping onto the location of New York, which seems to be related to arts and culture. So when they're talking about arts and culture, it tends to not be mapped to a specific location, which I find interesting. And then you can start to think about coverage that you think might actually be different. So again, crime we see in Rikers Island, and arts and culture goes down below. And I guess the other thing we see is that arts and culture is quite heavily focused in Manhattan. We don't see a lot of those blue dots anywhere else. And then finally, again, this is in progress, it's not developed, but you can map some of this to underlying demographic data, which starts to get at some of these biases that I was talking about. So if we look at the number of articles, then the three things that seem to be quite heavily correlated in terms of in a zip code are things like, what's the population of that zip code is going to be correlated to more articles, which makes sense. What's the percentage of people that have a bachelor's degree also is correlated, and starts to make you imagine, again, what those biases could be. And then this one was interesting to me, is that actually we see age being inversely correlated with number of articles. So that is something to dive into. I will say, just lastly, if you throw all of this into a model, age actually goes away as a predictive variable, so it could be just correlating with something else. But in terms of possible applications, so I do think this has the potential to be a low-cost and flexible auditing platform for local newsrooms. We've had a couple of these conversations. I would certainly love to keep having them to see how this could be feasible. I think, again, if you're mapping a lot of sources, you could start to get a large-scale understanding of content deserts. And then I would be really interested to extend something like this beyond news article data. You could think about the city council data for that. I will pause here to say, I guess the two things that are stuck in my mind with this are this question of bias, where we know there is less local training data. And so we started in New York because that's what our context is, but that is the one place that's going to be heavily covered, which does not mean the inequalities there are not important. But I think we would need to do this elsewhere to see how it does or does not scale and what the implications of that might be. So with that, thanks everybody. And if you want to have discussions, I know.
The last of our terrific presenters today will be Arijit Paladhi, who is a PhD candidate with the Media School at Indiana University in Bloomington. He is interested in exploring why and how the scope, power, and business of journalism is shrinking in a world where its need is even more pressing today. His goal is to explore and research the nuances of why it's on the decline, how it can combat disinformation and misinformation, and how we can evolve the idea of press freedom. He is the co-author of the paper Predicting News Deserts Using Supervised Machine Learning. So thank you.
Thank you. Can you guys hear me like this? Is that okay?
No.
No?
I'm going to stand up for people who don't hear well, of which I am one.
Okay, thank you for being here. I'm just gonna breeze through this so we can have a discussion at the end. I don't think, how much time do we have? 15 minutes?
Use the mic, please? Yeah,
should I?
Use the mic.
Oh, okay. All right, so the topic that I'm talking about is predicting news deserts using supervised machine learning models. We are sort of going through a crisis for the ages. We all know what news deserts are. We all know that local news is suffering. We have 10 people in the room who care about local news. Look at this. Very sad. I'm not going to go through what news deserts are. We already know that. It's essentially communities that are underserved, with no local news coverage or very sparse local news coverage. And in less than 2 decades, lost a quarter of the newspapers in the country. The civic engagement is declining. Democracy is threatened, all of that. The underlying concern is we are looking at research where we're mapping news deserts, but there's no definitive mechanism of predicting which counties might be at the most risk, right? So this is what I'm trying to do. Existing research limitations focuses on mapping current news deserts, lack of predictive modeling. The study objective here, and I'm going to talk about this in a little more detail, is that if you can develop a predictive model to identify counties at risk, it sort of becomes like an early warning system that you can have a targeted intervention for. The value, again, if a community is threatened, if a community doesn't have access to local news, the chances are people will be disengaged, democracy, civic engagement, all of that suffers. Now, the factors that I have looked at specifically for predicting counties at risk is population density, median household income, education, county level GDP, political affiliation, broadband access, and demographics, race and age. There are 2 things I want to speak about specifically why population density and not total population is because dense markets can help newspapers capitalize on both production of scale as well as economies of scale in both production as well as distribution. And that makes it more resilient to economic pressures that can eventually lead to news deserts, which is why I argued that population density is a better metric than total population. And the second is county level GDP. It's only very recently that the county level GDP has become accessible, maybe within the last couple of years. So it just makes sense that if a county's local businesses are flourishing, it is highly likely that they will be advertising in the local newspapers, which is why it makes empirical sense to involve county level GDP as well. The rest of them, there's been a fair degree of research which looks at the correlating factors. Napoli has done it, Stonebully has done it. There's a bunch of other research papers that look at what are the correlating factors in news deserts and socioeconomic indicators. Methodology. There are two interaction terms that I specifically use. One is the interaction between population density and GDP, and the other is between median household income and broadband access. The other thing that I'm going to speak about very briefly is the idea of how news itself, news or access to news itself is not a county's own feature. Sometimes your neighboring counties also bleed into it. And according to spatial journalism theory, the argument is that news and information dissemination are influenced by the geographic space in which it exists, right? So what we have done is using the socioeconomic features that we just talked about, all of them, we look at a county and all the neighboring counties weighted by population and what the influence of individual socioeconomic feature is on that county. Hypothesis, fairly straightforward. Advanced machine learning models, when combined with appropriate resampling techniques, can address, effectively predict US counties at risk. Incorporating interaction terms can help us improve the predictive power. And lastly, including socioeconomic characteristics of neighboring counties enhances the model's predictive power. The methodology, again, I'm not going to go into this in detail. The classifiers that we used are logistic regression, random forest, XGBoost, KNN, SVM, and naive Bayes. And the resampling methods are SMOTE. I'm going to talk about this a little briefly about why the need for resampling in the next slide, but these are the resampling methods that we use. Essentially, the argument is that the data set that we're using, the 3,000 odd counties, it's an imbalanced data set. Out of the 3,000 odd counties, there's only like a 7% percentage of counties which are actually classified as news deserts. So if out of 3,250 odd counties is what you have as news deserts, the data set is obviously severely imbalanced. So resampling methods essentially just helps us balance the data set. And to do that, we use these methods. Synthetic minority oversampling techniques, SMOTE, SMOTE and TOMIC combined, SMOTE and edited nearest neighbors, and adaptive synthetic sampling, or as I like to call it, sensitive SMOTE. Excellent. Yes, so like I was just saying, there's a class imbalance issue that we just talked about. Classification algorithms obviously focus on the well-represented class, which is the majority class here, which is the non-news deserts class. That's why we use the resampling methods. The data sources are the primary one is, and this is a limitation argument as well, that I'm focusing majorly on outlets, not news ecology or the content of it. So the data set that I'm using is the Abernathy and Franklin one from 2022, the State of Local News. Socioeconomic data comes from the ACS 5-year census data, MIT election data, USD Economic Research Service, and the US Bureau of Economic Analysis. Now, this is the context that I want to speak about a little more briefly. The idea, the research objective for this project is to minimize the number of false negatives. And why that is so is because predicting which counties are at risk, so if you just look at the slide, I'm not going to go deep into the true positive, true negative, false positive, and false negative. The argument is when you're looking to predict what counties are at risk, what's worse, flagging a county that it might not be at risk and you do flag it, or is it worse that you miss out on a county which might not be at risk, which is at risk, but the system doesn't flag it? My argument is that missing out on false negatives or missing out on counties that are at risk is worse. To that end, the primary goal is to reduce the number of false negatives. And to do that, what we do is emphasize the recall aspect of the model. We give preference to recall, and in order to do that, we also look at the trade-off between precision and recall, which is the F2 score. And again, not really going to go into this, but the area under the PR curve It's a score between 0 and 1, which sort of gives you an understandable trade-off between precision and recall. And so if you look at the recall scores, you see, for example, the NB model with SMOTE as the highest recall, but you have a precision of 0.08. What that basically means is that, so again, think of it as an example. If you look at the world around you, you have your smoke alarms, which have the highest recall, because would you rather have a house burn down or wake up at the middle of the night with like your smoke alarm going off? And criminal jurisprudence, on the other hand, looks at precision, which is higher. So the idea being that don't charge a person who is not guilty, even if that means letting a guilty person go free, right? So in this case, the idea is that the smoke alarm is going off throughout the night. Not a good idea. The other is precision, where the precision is high, and it's bloody Gotham out there. You need Batman because everybody's a criminal roaming the streets. So much like diplomacy, the trade-off is the F2 score, where everybody's unhappy, right? And to that end, the best three models that we get out of this is the XGBoost with the resampling technique Addison, Random Forest with Smotine, and XGBoost with Tomic links. I have been playing around with trying to increase the F2 score and recall, but this is the best I've been able to get so far, which is not really very high. I would take something above 0.6, but this is the best I've gotten so far. Again, this is like the Snyder cut. Everybody's unhappy. And last but not the least, so this is the feature importance part of it that I want to talk about very briefly. If you look at it, the predictive power, most of it is explained by, a fifth of it is explained by the population density and GDP interaction, like 20% of it. And it just makes sense because, again, if you're looking at print newspapers, the idea is that if population is dense, they will want some source of information. And if it's a dense population, the likelihood is that the county is doing well, the GDP is high. So just within those two metrics, there's a significant amount of predictive power. If you look at the top 5, Hispanic, Latino, what I was surprised by was that arguably black percentage at a county level should have been higher, but the systematic and systemic underinvestment in minority communities is obviously reflected in how Hispanic, Latino, minority population being at a county influences the possibility of the county being a news desert. GDP, 7% broadband access, which should be slightly higher, I feel, but it's 5% of the predictive power of the model, and the rest, as you can see. Interesting enough, I was going through the most recent State of Local News 2024 report, and turns out Edwards, Texas is already a news desert. So great for me, sucks for them. And so this is, I just looked at the 90% or hovering around 90% probability of counties at risk, and this is the list I have. Like I was saying, Edwards, already a news desert. Kent is hovering. In the most recent report, it says that it's very close to becoming a news desert. Predicted probability, I would say that take it with a grain of salt, obviously. There's nothing called absolute certainty, except taxes. Key takeaways, population density and GDP are significant predictors. Interaction term accounts for almost a fifth of the predictive power. Potentially, we should look at SML models in tandem with resampling techniques to look at what counties might be at the highest risk so we can have targeted interventions. And essentially try and have, spend some money. Because effectively that's the argument, because it is money that's all about. That's why we are suffering, and so is local news. Anyway, thank you.
In the very little bit of time we have left, I'm going to suggest, I'm not going to exercise the moderator's prerogative and ask a question of my own. I want to give maybe a couple of you a chance to ask a question, so I'll come to you with the mic and then I'll come back up here. Yes?
This is for Kai Cheng. So cool idea. I think the KL divergence is very interesting. It's very predictive. It occurs to me that the sort of errors you would expect there are sort of like geographically concentrated news outlets that are local news. The way we think about it, like trade press for geographically concentrated industries like Axios and Semaphore reporting on DC, but not really being local news for the people who live in DC. Is that what you see, or like what sort of errors do you find?
Thank you. I think that's a really good point. We haven't really got into the error kind of analysis phase yet, but I think that would totally make sense because we don't really, we're a pure data-driven process. People sharing those news, all that could be because of all different kind of reasons. So there's definitely going to be some errors. So, but thank you for the point.
It is actually 5:30, but maybe one more. The clock is slow.
Thanks, this is for Marianne. I have to really speak out to you. I thought your example of using an LLM to resolve local context was really interesting. And there's the case of the 7-Eleven 2 doors down, and then there's also the case of Dumbo. And it occurs to me that the case of the local is relative, because there might be a 7-Eleven 2 doors down in every city. But the Dumbo is a token that's unique to the place. Did you see that an LLM was able to do both of those kinds of context resolution, or was better one? I love the Dumbo example, basically. Yeah.
Thank you. So I think the short answer is we have not gotten yet around to validating those separately.
Yeah.
That would be what we're trying to do with the expert data set. I will tell you though, we actually handle or think about those cases slightly differently, as in the Dumbo example, we're relying, like we say, on some sort of context that the model has outside of anything that we're providing it. For the disambiguation, we are doing a specific process where we first ask for the locations that it thinks are represented in the article, and then for each location, we basically have a second disambiguation step that says, can you give us more information that will allow us to geocode that precisely? And the thing we have not yet done is basically looked at, how much does adding the disambiguation step increase the validity? And the reason for that is because the metric right now that we're using for validation just is not going to let us have that level of precision. So thank you.
We can pretend that clock is accurate. Maybe take one more.
So this is for both Marianne and Arijit. Yeah. This is my first time hearing of news deserts. Yeah. And I just want to be clear, are they places that are kind of underdeveloped? I mean, necessarily, or they're just places that don't have news or media houses around them? Also for Marie, did you use your model in a predictive context? And if you did, how efficient was it?
Yes. That's the answer to your question, yes. They're underserved, or either doesn't exist, or the coast shells of actual newsrooms. So, yes.
No, we're not. So right now we're thinking of it as labeling, so it's not trying to predict which locations are there. I would argue the very last slide, that's regression analysis, that's one kind of predictive model where we're trying to predict the number of articles in a zip code that will be written based on the demographic factors that we have. But I haven't thought about using it in that way, so I would love to hear your thoughts on that.
Okay, well, I think that wraps it up. So thank you so much to our terrific presenters and for your attention to this important presentation. And I understand that this has been a very long day for most of you, so thank you again.
Thank you.